See, for the practical class, I'm taking only one group, plus another group is also there who are doing practical class in some other time, isn't it? Only 50% students attend in my laboratory class. Therefore, in theory class, we have to take everything into consideration. So, I think this particular program we have already executed on the lab in the microprocessor kit 8085, isn't it? But since for the completeness sake, again I am telling the same problem, because another 50 students I do not know what is their progress and how much they have covered. Okay. So, it may be a repetition for the group those who are doing in my laboratory class. Okay. But from this program we can learn most important thing, how to write the assembly language program and how to maintain the lab record. Okay. And this is the exact way of writing the assembly language program, irrespective of any type of microprocessor, whether you take 8085, 8086, because every microprocessor is dependent on its own assembly language. Okay. So, therefore, we should go for this particular format. So, this is important for the laboratory point of view, but as far as the theory class is concerned, I think this much is from this line right side is important from the theory examination point of view. For the laboratory, the everything is important, right, because we do not expect to remember the hex code. And the problem is very simple. What is the problem? Problem is to add two 8-bit numbers with 8-bit sum. That means, we are only keeping track of 8-bit result which will come after addition of these two 8-bit numbers. Is that the problem is clear? Okay. So, again this program may be performed in various possible ways. Here if you see the problem statement, addition of two 8-bit numbers with 8-bit sum. I have never mentioned the memory location address, or you should take the register. So, any way, there are number of ways this problem can be solved. We can have different types of solutions. So, this is one such solution. So, already I think we are acquainted with the instruction LXI H800H. So, what is the meaning of this? That HL register pair will be loaded with the value 8000, or in other words, H will be loaded with 80 and L will be loaded with 00. Is it okay? Clear to everybody? Because most often this instruction we shall be using in the program. And already I have told you that HL register has some significance. It is a special register pair apart from your BC and a D. BC and D they are also register pairs, but HL is having a special role. What is that special role? We do not have a register called M. Is there any register M? No, but it is referring to a 8-bit memory location whose address is in HL pair. Is it okay? So, the moment you store HL value with 8000, it automatically indicates M. M means the memory location 8000. Is it okay? And this memory location content will be transferred to accumulator, move A, M. That means, we got an 8-bit data loaded into the accumulator A. So, third instruction, now you have to access the next location, because next location will be 8001. So, instead of writing INSH, if I write INRL, will it be sufficient or not? Will it work, or the problem is erroneous? The program is erroneous. Suppose I am writing INSH, so HL will contain 8001, but I will not write INSH, I will write INRL. That will also HL also will contain, because HL will not be affected. As long as you have not executed any instruction, H value will not be affected, and just I will increment L value by 1. That will be also okay. That is why I told you there are many ways to solve the same problem. In the place of INSH, you can write INRL, but that time the hex code will vary. It will have a different opcode. Is it okay? So, now if I write INSH, it is also correct, and if I write INRL, that is also correct. For incrementing a register, single register, you have to use the opcode INR, and for register pair, you have to use INX. So, if you practice a number of problems, automatically you can remember when to use INX and when to use INR. Is it okay? Similarly, we have DCX and a DCR. The way we have INX, INR, we have DCX, DCR. So, now HL will be incremented by 1. The meaning is that H content will remain 80 and L content will be incremented by 1. So, as a whole HL register pair will hold the value 8001. Now, we are referring to a memory location whose address is 8001 and that is the meaning of M. So, this M and this M are different because they are referring different memory locations. Now, we got the second data in M which will be added with the accumulator. What accumulator is containing? The previous data, previous 8-bit data. Now, the previous 8-bit data will be added with the current data, that is M, and the addition will take place and the result will be stored in accumulator because of this instruction. Is it clear? So, now because of this instruction, store accumulator content in the memory location whose address is specified in the instruction, that is 8003. Okay. So, that means accumulator content will be stored in the memory location 8003 and finally halt. And if you try to find the content of 8003, you will get the result, right. So, this is about the logic of the problem and which is very important from theory point of view, and you can go on adding the comments on your own ways, but try to avoid writing the comments instruction wise. Do not try to explain the meaning of the instruction, that is supposed to be understood by us. We do not have to exclusively write the meaning that moving the content of memory to accumulator. Do not write like that. Rather, write what is the meaning of a block of instructions. Or just to give one line comment in English, okay, this program adds to 8-bit numbers and stores the result in memory location 8003. That is also sufficient. So, your comment should be logic specific instead of syntax specific, semantic specific, the meaning of this program. Is it okay? And you can write on your own way. There is no hard and fast rule. And if you write your comment very well, you whenever you refer your program, you can easily understand and others can easily understand. This is what we call documentation, and this is also necessary for high level language codes. Whenever a software is developed, we also maintain the corresponding documents. Just like user's manual, that 8085 kit is available and a manual is there. Why the manual is there? Because to operate that kit, we have to refer the manual. Sometimes some manuals are very poorly prepared and some manuals are very seriously prepared. So, you can just by observing the manual, you can know many things, right. So, like that. So, you have to write the comment statement in such a way that your program logic should be clear to you as well as the others who are see your program. Okay. But as far as the practical laboratory class is concerned, this left part is important. Why it is important? Because we have to store this program starting from a memory location address which from where the execution will begin, and for that you have to know that which locations are reserved for the system routines. And already I have told you from 002 C000 try to avoid these memory locations because these are storing the system routines and implemented in the form of ROM, PROM, EPROM, etc. Okay. So, 8500 I think is a valid address from the practical point of view, right. And since this is a 3-byte instruction, you have to specify 3 memory locations. One is 8500, second is 8501, then 8502. So, 1 will be 21 will be stored in one location, next location will store 00 and next location will store 80. Is it okay? Then what will be the next memory location address? Just skip 3 bytes. So, you will get 8503 because 00, 01, 02 will occupy these 3 opcodes or hex codes. Okay. So, 8503 will store 7B and that is 1 byte instruction, move A comma M. So, next location will be 8504 and similarly 8505, but here you can see 8506, 07, 08 will store 320380 because it is a 3-byte instruction. We can have 1 byte instruction, we can have some 2-byte instruction and we can have 3-byte instruction. Okay. So, this is the addition of 2 8-bit numbers with 8-bit sum. Similarly, let us take this is the example 1. Let us go to another example. So, okay, so now the problem is slightly changed, that addition of two 8-bit numbers with 16-bit sum. That means, after addition we may get the carry, and a carry will occupy a complete memory location, and result will occupy one complete memory location. So, and assume that all other things are there, that comments is there, mnemonics, the way I have written in the first program, in the same way you can write the second program. But for saving the time, I am just writing the most important part. And sometimes what happens, you need not give the memory location address. For that you can use label. You can see there is a section called label. In the label means, in the place of memory location address, you can use some text in English. For example, in this program I have written level 1, level 1. Even if you write XYZ, here XYZ, there is no problem. But try to use the label in such a way that the readability will be more. You can understand why you are writing the label. Is it okay? So, you need not mention, you can see in the second program, I have never mentioned where it is stored, where the program is stored. Labels will be sufficient. You need not write the starting address or ending address of this program. Is it okay? And that is the use of label. And the label should not be too short or should not be very big. Because if you write a big label, what will happen? It will occupy sufficient space, and whenever you use too much labels in your program, what will happen? The program will not be structured. So, try to use the name of the label and number of labels judiciously to make your program more understandable. Okay. So, anyway, so this is the program for adding two 8-bit numbers with 16-bit sum. The first one I do not have to explain much, because HL will be loaded with 8501, right. Then F2 move immediate M F2H. What is the meaning of this? F2 is the 8-bit data which will be stored at memory location 8501. Am I clear? So, move immediate M comma F2H means F2 is the 8-bit data, move immediate addressing. So, F2 will be stored in a memory location. Which memory location? That is specified in HL register pair 8501. So, F2 is the data stored in the memory location 8501. So, now 8501 will contain F2 after execution of the first two instructions. Is it clear? Then coming to third instruction, INSH. INSH means HL will be incremented by 1. That means now HL is storing 8502. So, next memory location is 8502. So, this time 2F will be stored in the memory. M means 8502. So, now 2F will be stored in the memory location 2502 after executing first 4 instructions. That means, why you are writing these 4 instructions? Because we want to store two different 8-bit data in two consecutive memory locations. Two consecutive, by default it will go to the next location. That is so, in the while writing the comments you can write load two 8-bit data into the two consecutive memory locations. And if you write 8501 and 8502, it is good. That is how you can write the comments. Okay. So, now move A comma M. What is M? What is M now? So, M is still 2F, because we have not modified the memory location. So, M value is 2F. 2F will be stored into the accumulator. Move immediate C00. We will come to will understand why we have taken another register C. There is a purpose behind this. Okay. So, DCSH. DCSH means when you move memory to accumulator, so current memory location is 8502. So, 2F is stored into the accumulator, and the moment you write DCSH, we are referring to the 8501, and this time M is F2, memory content is F2. Is it clear? Again I am telling. So, unless until you have modified the HL value, the M value will not be affected. Unless until you have modified the HL value, M value will not be affected. So, since we have not changed the HL register pair values, so M means this M and both this M and this M both are same, or its contents are same. So, their content is 2F, because now current HL register pair is holding the value 8502. Okay. And after storing 2F into the accumulator, we have initialized C to 00, that is a different things that we shall see. Now, DCS H means it will be decremented by 1. Which one? HL register pair will be decremented by 1 referring to 8501. So, now add M. So, what will be added? A with M, and A already you have stored the second data, that is 2F. Now, M value is F2. So, F2 and 2F both will be added and the result will be stored into accumulator. Now, accumulator is holding the data. Okay. Now, we have to consider whenever the addition takes place, the carry may be generated or carry may not be generated. So, whether it is generated or not generated, we have to take care of the carry. If the carry is generated, 1 will be stored in that location, and if the carry is not generated, 0 will be stored. But we have to have that feature in your program. So, you may be thinking that carry is not generated. So, all the time you take a small data, carry will never be generated, and you neglected the carry. So, that is our program will not be complete. Therefore, whether carry is generated or not generated, you have to write a generalized program, so which will consider the carry into account also. You cannot ignore the carry part. That is the, because our problem says addition of two 8-bit numbers with 16-bit sum. The meaning is that carry must be included, taken into account, whether it is generated or not generated. So, jump no carry. No carry means what? That means after adding 8-bit numbers, the result do not have any carry. So, INRC, jump no carry means carry is not generated and go to this location. Okay, we will come to level 1 afterwards. Assume that carry is generated. So, what will happen? By default, the next following instructions will be executed. If the carry flag is not set, then the control will go to level 1. If the carry flag is set, jump on carry, the next following instruction by default will be executed, because that follows the von Neumann stored program computer concept. Always your program will flow from top to bottom unless until there is a branch, unless until there is a transfer of control. Okay. So, control of execution will be executing the next following instruction if the condition is not satisfied. So, if the carry is generated, the condition is not satisfied, therefore, INRC, C will be incremented by 1. Remember, we have already initialized C to 0 0. The meaning is that this time we encountered a carry. And how did you know that carry is generated? Because carry flag is set to 1. If your result is generating a carry, carry will be set to 1. Is it okay? So, now C is holding the value 1 if the carry is because carry is generated. Therefore, C is holding the value 0 1. Now, store accumulator. Accumulator is holding the result. Remember, C is holding the carry part, and 8-bit results are still available in the accumulator, and accumulator content will be stored in the memory location 8503, right, and move C to A, because accumulator was holding initially result, but again we have to store the carry in the next memory location 8504, but what to get carry? Carry is there in the register C. So, transfer the value of C to again accumulator. Now, accumulator the previous content of accumulator will be changed, modified, because previously it was holding 8-bit result. Now, it will be holding 8-bit carry. 8-bit carry means only the last least significant digit will be 1 and the remaining bit will be zeros, and that to store in 8504. Is it okay? Now, suppose the condition is satisfied. What is the meaning? Carry is not generated, and just skip this instruction. You do not have to execute INRC. How to skip? It is called a forward jump. Forward jump means the level 1, it will search where is level 1. So, basically level 1 is a memory location address where the control will be transferred, a physical 16-bit address. And if you are using an assembler, assembler will automatically convert your label to the corresponding physical memory address. But here we are not using assembler, we are writing our own program. Therefore, you have to keep track which location you are using as a label, so that you can exactly write the proper location where the control will be transferred. Now, jump no carry level 1 means you cannot write level 1 here, you have to write here. If you write here, what will happen? Again C will be incremented by 1. So, if you do a small address mistake, So, the entire result will be erroneous. So, you have to find out the exact location to which the control will be transferred. So, if the carry is not generated, only you are storing the result, and what is the value of carry? 0 0, because C is not incremented yet. C is not incremented, therefore, 0 0 will be stored. Is it clear? So, if the carry is generated, you store the result along with the carry value 1 in 2 different locations, and if the carry is not generated, you store the result and consider the carry is 0. That is all about this program. Okay. So, this is the main logic of this program, but the other parts, like you can use the hex code in the left side, and you can use the comments for understanding sake or for documentation sake, so that the program will be complete, right. So, this is once you write this part of the program solution, your 50% of the task is over, but the remaining 50% are with the comments and the labels. Is it okay? So, this is addition of two 8-bit numbers with this 16-bit sum. 16-bit sum means both carry, the carry is taken into account. Let us take another problem. Addition of n 8-bit numbers. Here there is a confusion. Since microprocessor is a finite state machine, I think theory of computation everybody has studied, finite state automata. So, since it is a finite system, the memory is finite, microprocessor capability is finite, devices are finite. So, n has no meaning. Therefore, what you can, in the place of n, what you can do, assume that n is referring to a memory location where some values are stored. Suppose you store 10. So, 10 numbers are stored and 10 numbers are to be added. So, best way to represent n value in microprocessor assembly language program, assume a location and store an arbitrary value x. So, that is how we represent n. Otherwise, n has no meaning, because number of locations are limited, number of registers are limited. How can you add an n bit numbers? Suppose n is more than some 1000 or lakhs, then it is not possible to add, your system will not take, and every microprocessor has its own limitations, as I told you. So, n bit means assume that n is a value which is available in a memory location. Is okay. So, the solution is like that. Okay. So, addition of n 8-bit numbers. So, this is the memory locations. N different 8-bit numbers are stored in different memory locations. You have to add them and store the result into some memory location, that is F200 and F201H. So, LXI H F100, clear, HL is loaded with F100, move C comma M, M means F100, and F100 content will be stored in the register C, and XRAA, what is the meaning of this? Accumulator will be cleared. Accumulator will be exclusive with the accumulator. So, wherever 1 1 is there, 0, 0 0 is also 0. So, either you can write move immediate A 0 0, or you can write XRAA. A content will be exclusive, B2 is exclusive with the A, and result will be 0. That means accumulator is initialized to, our purpose is to make accumulator initialized to 0. Okay. So, why you are initialized to 0? Because you are doing the summation. If from previous value will be there, your result will be wrong. Therefore, it should be cleared. Is it okay? Then move immediate B comma 0 0. Now, 0 0 will be stored in B. Can you guess why you are using register B? Why the register B is required? Because you have to know which what are the memory locations, what are the registers used in your program, and why it is so. When you have to use the registers judiciously. Only we have very few registers, and if you don't use properly, what will happen? There will be shortage of registers at the last, your program will be wrong, because you cannot find the register left to continue your program. Some big programs are there, so you have to see each and every register and the purpose behind of using those registers. So, it is clear that in like your previous program, that B value is initialized to 0 0 to keep track whether carry is generated or not. but here in this program the carry may be generated in every successive addition, because you are adding n bits. First 2 8 bits you add, there may be carry generated or may not be generated, but the partial result will be added with the next 8 bit. So, again carry will be generated, and after some time we will see that every time you add a number to the partial result we will be generating with a carry. And our purpose is that how many times you generated the carry through the addition process, you have to keep track. So, the moment is carry generated, you increment the register B by 1, and whenever the carry is not generated, B will be not be executed. Therefore, INRB is just written inside the loop. Okay, we will see that one. Now, INSH add M. What is INSH? Now, HL will be containing F1 0 1, which is holding the first data item, which is to be added, and added with whom? Accumulator, and accumulator is storing 0 0. Then you may be thinking, what is the use of F1 0 0? What is the use of F1 0 0? Because you are taking the first data item, adding with the accumulator, isn't it? Then why you have used F1 0 0? The moment I clear the accumulator, I assume that accumulator is holding one data and the next memory location M is holding one data, and both will be added together and the result will be stored in accumulator. Then why you are using F1 0 0? So, F1 0 0 is the memory location where n is stored. N means the number of items, data items will be added. Suppose you have 108 bit data to be added, then here n value is 100 and converted to hexadecimal. Hexadecimal means 8 digits in binary, that is available in F1 0 0. Is it okay? So, the number of numbers which are to be added, that is stored in F1 0 0, but the actual numbers are not available in F1 0 0. And where the actual numbers are available? Starting from F1 0 1. Is it okay? So, INSS means F1 0 1 add M, and A is already storing 0 0, 0 0 with the first data item added together and result is stored in accumulator. Jump on no carry. If the carry is generated, then directly increment B, and if the carry is not generated, skip that instruction. Very simple. Okay. Suppose carry is generated, so increment B, decrement C. Why C should be decremented? Because one addition is already taken place, and you have to decrement C. You keep on decrementing C, the value of F1 0 0 content, because we know how many numbers are there in F1 0 0, right. So, the moment one addition is over, decrement it by 1, and you will see that C value will be 0 when all n bits are added, and every time also we are keeping track of the carry, right. So, suppose C is decremented by 1, and unless all numbers are added, the C value will not be 0, and since C is not 0, jump not 0 loop. Go to loop, increment the memory location pointer and add with the content, and again check for carry, and if the carry generated, add increment B, and if the carry is not generated, skip it and decrement C and keep it in a loop, and this loop will carry on until the content of C is 0, and when the content of C will be 0, whenever all 8 bits have been added. Is it okay? So, jump not 0 loop, and when all the additions have taken place, the result will be there in accumulator and the carry part will be there in the register B, and we have to store in two different locations or two consecutive locations. So, accumulator value will be stored in F2 0 0 and accumulator value will be stored into F2 0 1 after moving the number of carries which is available in register B to the accumulator and halt. Is it okay? So, what we are doing here, that n different numbers are 8-bit numbers are given and all will be added together and the result will be stored in two memory locations. One will store the result, another will store the number of carries you have generated during the addition process. Is it okay? So, this is, and see, in the place of jump no carry, if you write jump on carry, the entire program is wrong. So, you have to be very careful while writing the conditional instructions. And in the place of jump not 0, if I write jump on 0, this will be also wrong. Only one addition take place and your program will come out from the loop. And here only 2 loops are used in this program. You will see that some programs you have to use 5 loops, hundreds of loops. There are programs where 100 loops are there. Therefore, comment and documentation is very essential. you should write which loop is used for what. So, in the place of LOP, if I write XYZ here, here if I write XYZ, this will also work, but by seeing this XYZ, I cannot know whether it is a loop or it is a forward jump or a backward jump. Therefore, try to use a label so that the readability of that, the meaning, the way you are using that should be clear. Is it okay? So, this is addition of n 8-bit numbers. Similarly, let us go for another example. Is that problem is clear? Addition of two 16-bit numbers with 16-bit sum. Okay? Addition of two 16-bit numbers with 16-bit sum. So, just I am giving 5 minutes time. So, I can give a hint. This problem can be solved in two different ways. One is with using LHLD and SHLD, and without using LHLD, SHLD, and you will see that how the efficiency is differing. There is a drastic difference in the efficiency. Only 5 or 6 instructions are necessary to solve this problem. It can be solved within 1 or 2 minutes. The solution, I have given you 5 minutes, but the solution is for 1 minute only. Then where you are lacking, only you have to be aware of the instructions. If you know, the logic is also very simple. There is nothing to understand here, only you should be acquainted with the instructions. Okay? So, with using LHLD, SHLD, now both are acceptable for us.